Hey, what's up guys, my name is Cherno and welcome to episode 112 of Game Programming. We are back. It has been like over 6 months, I think, probably at least close to that, which is absolutely ridiculous, but we're back, and hopefully I'm going to start pumping out videos a bit more often for you guys. So, obviously the reason I was away was because of university and whatnot. I'm back, it's the holiday season, I'm actually not going to be studying next year, I'm just going to be working, so that's a bonus as well. Basically, there should be a lot more videos. And so don't get too mad at me, okay? I'm sorry, but, you know, I did what I had to do. Okay, anyway, I promised you guys we would do Sprite Rotation. So, I mean, I can't just come back here after not making videos and break my promises. So we're going to be doing Sprite Rotation today. Now, a few things I want you guys to realize is that Sprite Rotation is not going to be, it's not going to look completely flawless, and it is going to be slightly difficult to implement, okay? Which is fine, we can do it, okay? I know we can, but just keep that in mind, okay? And one of the reasons is, if we take a look at our sprites, right? So if you go into your resources folder in your project and go to something like, let's just say textures, because the main thing we're gonna use this for is projectiles, right? So, or at least for now, at least. So in textures, sheets, projectiles, if you look at our wizard projectile, or if you just look at our projectiles in general, let's just edit this, right? In our beloved paint.net, you'll see that we're dealing with pretty low resolution graphics. Okay, we are dealing with fairly low resolution graphics. So what we're going to do right now is create a projectile for us to rotate. If we rotate this thing, we're barely going to see any difference, right? It's basically a circle. I mean, we are going to see a bit of difference, obviously, and there is this thing here, and it's not, you know, it's not completely, it's not really, you know, if we rotate it on 45 degrees or whatever, there will be a bit of a difference. But let's just draw something that we can actually see in action, like a line. Basically, we're just going to make like an arrow projectile. So I'll copy and paste this thing, move it all the way over here, and let's just make this arrow. So I'll delete this. I'm just going to draw this black line here just for now, so I can see the bounds. Okay, so this arrow is going to be pretty beautiful. We're going to draw it in, I don't know, we're not going to really, there aren't really any rules to follow when you're drawing this, by the way, so don't be too afraid. I'm just going to kind of try to make it look good, which is always a struggle, but you know, that looks terrible. Is that right? That's right, okay, that's symmetrical. And then we'll give it a bit of like a tail, you know, because that's what arrows look like. Alright. Maybe one less. How's that look? That looks pretty good, I think. There you go. So there's our arrow. It looks pretty good. So rotation, right? This is going to be rotated. Now we can rotate this on any degree. That's how we're going to make this. We're not going to make it so that we can only rotate it by 90. Now, this was a very heavily requested topic. I'm not going to lie. Sprite rotation was very, very, very high up there in terms of how many people asked for it, okay? And of course I do read the comments to my videos, so I was reading through some of my videos, and people were pointing out the fact that it's pretty much impossible to do because of the fact that you'll notice that if I try and rotate this, right, if I can even remember how to do it in paint.net. Okay, here we go. So there's this little rotation thing. If I rotate this, yeah, you will notice, and let me just change the quality to nearest neighbor so that it doesn't anti-alias it. If I rotate this, you'll notice, look what's happening. Yeah, if I rotate it 45 degrees or something close to that, look at that. Suddenly, our sprite does not take up our original size, does it? Yeah? A few things have happened. First of all, it takes up more size, right? It's wider, and it's taller than it was before. Second of all, it looks like absolute rubbish. But we'll get to that later. And you'll also notice there are blank gaps. There are void pixels that aren't there, and they're basically over here where I'm just moving my mouse right now. Okay? 3 issues. Okay? The big one is the fact that it now takes up more width. So how are we going to solve that? And it's very easy to solve that, okay? It's also very easy to solve this problem. The problem that we actually cannot physically solve is this, okay? This is kind of what it will look like, all right? Unfortunately. Why? Because it's just too low fidelity, right? It's just too low resolution. We have to deal with this, okay? But nonetheless, if you rotate it 90 degrees, you can see it's perfect, okay? And if we rotate it 90 degrees anywhere, 180 degrees, whatever, yeah, it looks pretty good, okay? And I think our end game is going to probably look a bit better than this. I don't know why this looks so bad, but the point is, with low resolution graphics, you're going to get these kind of, I don't know, problems. So that's the idea, okay? But the two things that people seem to be afraid of was the fact that you can see the sprite is now bigger, okay? It's kind of spilling out of its bounds. So one thing I would just recommend you guys to do when you're drawing your sprites, don't make them overly big, okay? If you want them to be rotated properly. So don't make, let's just say if I don't know why I'm drawing this stuff in black and white, but let's say I just wanted like, I don't know, I had this here for some reason. You're gonna notice that as I rotate this, right? It's actually, okay, no, sorry, it has to be close to the, my bad, it has to be close to the bounds, so I'm just going to continue drawing in black and white here. But if I had something up here in the corners, basically, like, I don't know, this red kind of thing, yeah, like this red thing here, and I was to rotate this sprite, you guys are going to see that it's going to go off, right? It's just going to go off. It's going to go off the screen. Yeah, so just keep that in mind. Try and draw your stuff to the center. You can see that the arrow that we drew is perfectly in bounds, which is fantastic. Okay, so we don't need to worry about that. But that's just a heads up. Okay, so I really don't know what the people were. I don't know why you guys were so scared about rotation in terms of spilling out of bounds. Like I would have thought that I taught you guys how to handle out of bounds stuff, and that's simply by skipping those pixels and not rendering them, and not, you know, obviously just, yeah, I mean clipping it. I mean, that's really how simple it is. And to do with this, we can just fill it in with a void color that we can then make transparent, such as pink, okay? So don't worry, this is not that hard. The algorithm is a bit hard, but we've kind of done it already, okay? We've subconsciously done it already. So I'm gonna put this arrow here. Now, I know this is in the wizard sprite sheet, so really, I don't know why this arrow is here, but we're gonna call this projectile arrow, okay? It's gonna be in the wizard. Yeah, just to save time, right? You guys can organize your sprites however you want, obviously, it doesn't really matter. So the first thing I'm gonna do is actually get this into the game, yeah? If I go into sprite, sorry, not sprite, sheet, sprite is what I meant. Now I'm selecting all text, what am I doing? Well, now I'm typing here. It's been a while since I made any videos on this. So projectile sprite's here, yeah, we'll copy and paste this. We'll call this projectile arrow, okay? We'll make sure it is the first. You can see this is 16 by 16 size pixel, 16 by 16 size pixel, that's great. 16 by 16 size sprite, okay, that's pretty low res. That's why this rotation won't really look very nice, but it will still work. That's what's important. And because the projectiles are traveling that fast, you probably won't even notice. Okay, so projectile wizard, and it's sprite number 1. So if we go back into our wizard projectile, which we fire, let's actually launch our game and see if it even works. Here, it does. I don't know why it appeared on my other monitor, but here we go. So it says, hey, what's up guys, my name is Cherno. Great, that's what I said at the beginning of the video. So we'll comment that out. So this font.render, yeah, get that out of there. And it keeps appearing on my other monitor, but anyway, here we go. Yeah, this is what it looks like. We're all good. Those are our projectiles. Let's hop into wizard projectile and change this to be projectile arrow. So now we're dealing with our new projectile. Okay, and there you go. So we're shooting arrows. Let's get rid of that black border as well, that black line there that we had in paint.net. So here we go. Gone. All right. Fantastic. So now you should be seeing an arrow that is obviously not rotating right now, but will. Okay. There you go. There's our arrow. Fantastic. So let's get into this. How are we going to do this? Well, it is a graphical operation, so I'm going to stick it in the screen right now. We could stick it in a sprite, and we'll see, okay? We'll play around with this. We'll get it to work the way we want it to work, but first of all, let's focus on actually getting it in the game, okay? That's always good. So right now, the way we render projectiles is by calling render projectile, this method right here. I'm going to copy its method, and I'm just going to add an angle. Now, this angle is going to be a double. It's going to be in terms of radians, okay? Where the reason it's going to be in radians and not in degrees is pretty simple, okay? Wizard projectile's angle is stored already in radians, and also cosine wants radians instead of sine, right? All the trigonometry operations want radians, not degrees, and it's already in radians, so there's no point in having it in degrees. It's in radians. Fantastic. Get used to it, okay? Okay, now over here though, instead of getting these sprite pixels, we want to actually physically rotate this sprite, okay? To rotate the sprite, we're just going to modify its pixels. Now, we're not going to modify the sprite's pixels, okay? We just want to make a copy of them. We don't want to permanently modify them, because next time when we go to rotate it, it's already rotated, okay? Apart from the fact that sprites are static, as you know, which is a good thing. What I mean by that is there is only one copy of this projectile arrow in our entire game. If we rotate it and we actually modify it, it's going to be different for the next entity that shoots, okay? So we want to make a copy of these pixels. So straight away, let's make a private method here, okay? It's going to be called rotate. It's going to return an integer array, which is going to be the new pixels that it creates, okay? It's going to take in the old pixels, which are essentially the non-rotated sprite, and it's going to return the rotated sprite. It's going to also take in a bunch of important information, such as the width and height, since we're not passing in a sprite. You know what, we could actually pass in a sprite, honestly, but we're just going to keep this nice and simple, okay? So we're going to keep this very universal, so it can really act on any pixel array. And finally, we also need the angle. We actually need 2 more methods as well, just to make our lives easier, but you'll see that a bit later on. Okay, so first of all, I like to start off methods by writing what I really want to return, which is going to be the result, okay? So the result's going to be a completely new pixel array, right? A new integer array with the same size as our old one, okay? Width times height, okay? Width times height should also be the size of this. Now, how are we going to call this? Pretty simple, okay? It's going to be pretty simple. Right now, we get the sprite's pixels, and then we look up that index. What we want to do is, instead of getting the sprite's pixels, we're going to get our own pixels. So I'm just going to call RP, R pixels, okay? These are going to be our rotated pixels. That's going to equal, we're going to grab this, cut it. It's going to be rotate. So we're going to rotate those pixels. The width and height is just simply going to be p.getSpriteSize. I don't know why we're using getSprite.size here if we've got get, anyway, I don't know. And then the angle is obviously going to be the angle that we specify here, okay, in radians. So there's our pixels. We're going to replace them with this over here. And now essentially we're just dealing with rotate, okay? That's good. That's all done now. If we were to run this, it will give us a black because all of these integers will be automatically initialized to 0 by Java. Okay, anyway, let's get started with the rotation. So we actually need more methods. We need 2 methods, okay? One's going to basically deal with the X side of rotation, and one is going to deal with the Y side of rotation, okay? I'm not going to hand execute and basically explain this step by step because it will take too long, but I will give you guys a rough idea of how it works, and it's really not that hard, okay? It might seem that way, but it's not. So first of all, we'll be returning, I'll just call this rotation X, okay? I know I'm kind of breaking the Java convention. I honestly think it looks better this way. But rotation X, okay? So this is going to, you can see it returns a double, okay? This is very similar to how we do projectiles, okay? When you think about it, right, what are we really trying to do when we rotate? We're trying to, let's just say we're rotating by 45 degrees, okay? If I copy and paste this, and I were to rotate this by about 45 degrees, well, that's exactly 45 degrees there, right? That's what I've done. What's actually happening? Well, we're taking, and I'm going to just use a different color for this, maybe like green. We're taking, let's just say this pixel over here, and we want to rotate it by 45 degrees. So we want to put it just about there, okay? What are we actually doing to it? Can you guys notice what's happening to that pixel? How is it moving? Well, it's moving, it's moving right and then down. Okay, so it's actually physically moving. Now, what angle is it moving on roughly? Okay, it's moving on negative 45 degrees. Okay, that's the angle that it's moving in. We want it to rotate it 45 degrees clockwise, which means it goes negative 45. Now, why is that way negative? That's one question I actually get quite a lot, so I'm going to answer that real quick. If you guys are not familiar with the unit circle, get familiar with the unit circle. Okay, if you've done maths in like high school or whatever, you probably know what I'm talking about, okay? And this is what the unit circle looks like. Let me just show this real quick here. I wasn't planning on showing this, but you know what? I thought it was important enough. This is what the unit circle looks like, all right? Now, what you'll notice, and what really is important for us, is the fact that 0 degrees, you can see, is right, okay? That's 0 degrees. It's going that way. Positive 90 degrees is this way, okay? 270 degrees is over here. It's also, if we go negative, obviously we're going down. So that's why we're going negative, okay? A lot of people think 0 degrees is up. It's not, okay? 90 degrees is up. 0 degrees is just horizontally right, okay? Down is either 270 degrees, 3 pi over 2 radians, or negative pi over 2 radians, or negative 90 degrees, okay? So thus, when we go this way, we're going negative 45 degrees. That's the angle, okay? Now, do we know how to move pixels based on angles? Yeah, we do. That's how our entire projectile system works, right? In our projectile system, look at this, nx and ny. What do? We take the cosine of the angle, and that's our new x, or that's the dx, that's the delta x, that's the direction along the x-axis where we actually move to, okay? And all we do to move our projectile is move it by that amount every frame, okay? Or not every frame, but every update, all right? That's how it works. This is the same way that this is going to work, all right? There's nothing cryptic about this. We're going to send this pixel and move it negative 45 degrees that way because we've rotated it by 45 degrees. And even I can't even write 45 degrees at this resolution, so there you go. That explains the bad rotation, but that's the idea. All right? Does that make sense? I really hope that makes sense. But that's basically how it works, okay? If we rotate it 90 degrees, obviously that pixel is going to be somewhere, I don't know, here, okay? And you'll see, like, if we rotate it, you'll see that, all right? But the idea is, you can see that we've moved it negative 45 degrees, all right? That's the idea. Yeah. So the first thing you'll notice is, well, you'll notice a lot of things, but if we rotate it clockwise, we want to say that clockwise is positive. I know that goes against the unit circle, but when we think about this, like, as a human, we think clockwise. If I rotate this 90 degrees, I'm not rotating it this way. Yeah? That, to me, looks like negative 90, even though technically it is positive 90. Okay? So we want to reverse this. That's why we're going to need to use negative angle. So you'll see me use negative angle quite a lot here. That's why, okay? It's because we're kind of overriding the unit circle and doing our own rotation. Thus, if we want this to be positive, if we write 45 degrees for this, it's actually negative 45, thus we need negative angle, okay? But that's how this works. So how do we figure out the delta x, delta y, whatever you want to call the variables, nx, ny, new x, new y? How do we figure out where to move that pixel? These are where these methods come in. Rotation x will figure out where to move it on the x-axis. Now, this is going to take in a few things. It's going to take in the angle, all right? It's going to return a double, which is going to be the new position of the x, essentially, based on that. It's not even going to be that, though, right? Because we'll actually do the animation in rotate itself, all right? And by animation, I mean the moving of this pixel down to this pixel, all right? But what this will do is simply return either, okay, this is where this comes in as well. We'll put double x and y. Now, these are not the positions. These are whether or not we essentially want to do it on each axis, okay? And I know it's weird because you're rotation x, but there's x and y, but, you know, we'll get into that. Don't stress too much. So the cosine is going to be very simple. It's going to be math.cosine. Now, we don't need to convert it into degrees. It's already in, we don't need to convert it into radians. It's not in degrees. It's already in radians. So we simply pump in the angle here and we're good to go. Now, there will be one more adjustment we have to make, but we'll do that later after I demonstrate this as it is right now. So we'll return x multiplied by the cosine, okay, plus y times negative sine, all right? And how does this work? This works exactly the same way that basic angular motion kind of works, right? Going, incrementing variables based on a pixel and separating the axes to get it in terms of x and y, essentially converting kind of vectors into more or less point space, where we're actually dealing with x and y rather than a direction and a length, which is kind of what a vector is. Anyway, getting back to this, we've got rotation x, we've got rotation y now. This is going to be the same. I mean, at least these two are going to be the same. This is going to be slightly different, all right? X is going to be multiplied by sine, and y is going to be multiplied by positive cosine. All right? Simple. That's the way it works, okay? That is how we can that's really all we need to get the direction for x and y of this, okay? I mean, we've got the direction, but to get the, I guess, the absolute position, the new absolute position of it, okay? So back in result, or back in rotate rather, with result, what we're going to do is we're going to have to figure out a few things. First of all, we need a new position. We need a new x and y position for this pixel. All right, so this pixel has two coordinates, x and y. All right, we need the nx, or the, I guess, the amount we need to move by. We don't know. We need to basically know the direction. Okay, we don't know how far we want to move it yet. That's what the for loops that we'll see later will figure out. This will tell us the direction it needs to move in. So -45, right? That's what we kind of figured it out to be. So I don't know what to call this. I'll call it probably something like nx. I mean, we'll go with nx just because we chose it here, okay? But this is going to be the x coordinate of the x, okay? Which is going to sound a bit tricky, but don't worry. It's going to use rotation x. It's going to use negative angle, right? I explained why. It's because of the unit circle and the way that we perceive this. This is going to be 1.0. This is going to be 0.0. Now you'll notice that if we make y 0.0, it's going to completely cancel out y, because y multiplied by -0, or y multiplied by 0 is 0, so thus it's really x times cosine, okay? That's how we can use this, all right? So we were only interested in the x coordinate. Now this is the y coordinate, all right? So the y coordinate is actually going to look exactly the same, except it's going to use rotation y, okay? Two more of these. So now we need them to do for the y pixels, all right? So we're just going to literally switch the names just like that. And then over here, we're going to switch this to be on the y, so it'll cancel out the x, okay? Pretty smart, if I do say so myself, all right? There you go. It's not like I created this. I mean, this is really common stuff to do, but that's the idea. Now, finally, what we actually need is an initial rotation pixel value, okay? To do that, I mean, well, we're just going to call this x0, I think. I'm running out of names here, because we also need the integer conversion, so there's also that. But we'll set this equal to rotation x, and this will be negative angle as well, but this is going to be a bit different, all right? It's going to be negative width divided by 2, negative height divided by 2. This is probably the most complex part of this entire algorithm, and plus width divided by 2, okay? And the y version of that is going to be kind of simple as well. It's going to be rotation y, obviously, and it's going to be the exact same, except we're going to add on height divided by 2 instead of width, okay? What is this going to do, okay? That's the tricky part. This is going to be the initial value of the pixel before we add on all of our actual direction or directional vectors, okay? This is the initial value of it, okay? Based on the angle. Now, where this goes and whatnot, this kind of depends on, how should I say this? This kind of depends on the source pixel, okay? So all the colors are, yeah, remember, all the stuff that's in pixels, that's just a bunch of colors. So the only reason we need this original pixels array is just to see which color. But when you think about it, we know the size, we know where we want to rotate it to, yeah? So we don't need color for that. We don't need this pixels array at all. The only reason it's there is so that we know which color to put where, okay? But the point is, we don't need it to figure out rotational vectors and whatnot, okay? We know that it doesn't matter what is inside these bounds, yeah? If I rotate it 45 degrees, it doesn't care what's inside, okay? That is what this does. That's why it's just some number play, okay? Now we get to the actual rotation. So we know the initial positions. We know the positional. I shouldn't really call them vectors because they're separated, but we know the separate x and y directions for travel, essentially. So now what we need to do is actually go through the for loop that will move the pixel into the right location. Yeah. So we figured out this. This is essentially x0 and y0. We figured out this, that's where, well, I mean, we haven't figured out this yet, that's what the for loop will do in a minute, but we figured out which direction this lies in and how much we need to move on the x and y, okay? So now all that's left is to actually move this into here, all right? So how are we doing that? Well, we'll make a nested for loop here. It's gonna do this for every pixel in our array, so thus it's gonna be width by height, as I'm sure you guys are aware. All right. Now I am gonna make x1 and y1s just because we'll need them, and you guys will see that in a minute. But basically these are just copies of the initial starting locations because we're going to animate it now. So to animate it based on X, and remember we have to animate it both on X and Y, this is just going to do it for the row. So the row, if we look at the first row, yeah, that's going to get rotated and become somewhere here. So obviously both the X and Y position changes, hence we need the X and Y. So the first row, yeah, well that's what's going to happen to that is essentially, okay, let me think about how I want to write this to explain it better. First of all, let's just convert them into integers, right? X1 and Y1, we'll convert them into integers because we need to draw them in terms of integers. The reason I've got them as doubles is obviously because all these operations are using sine and cosine and we want them to be fairly precise, and I made a massive mistake here. Make sure this says sine, okay? So we got the sines and the cosines, obviously. So we'll, so they deal with sine and cosine. Obviously we want some pretty high level precision, and in the end we just convert it into an integer so that we can actually draw it. Since pixels, we can't have half pixels or whatever, they need to be integers, especially because this is an integer array. Okay, we got that now. So what we essentially want to do is set a variable here. We just want to really set the result, right? Now what index in the result? X plus Y times width, right? Pretty basic stuff, same way we draw it. Yeah, this is an accent. This is a simple width height XY array. Sorry, for loop structure thing. So we obviously just want to draw it that way. And then we just set that equal to the color. Okay, what is the color? The color is just based on the original array. Now, what index in the array though? It's going to be our rotated index. That's what we're trying to figure out. Yeah, we already know what the width and height of the new one's going to be. All we want to do is basically move this pixel, right? And the way we move the pixel is we figure out the index of this pixel based on where it is in the old array and copy it into the new location in the new array. Okay, that's how it works. That was a mouthful to say a bit. So XX plus YY, and guess what? The width is going to remain the same, isn't it? We're not changing the width, so the width remains the same. The only thing that changes is the actual index, okay? And that's going to be, well, the X and Y coordinate, I should say, because the whole thing's an index. And that's going to be based on our calculations here. So that's the result, yeah? All we do is we increment X1 and Y1, which are the ones we use kind of for X here. We increment them based on the direction. That's it. So NX underscore X is what we use here, and NX underscore Y, okay? So you can see the first kind of thing refers to this for loop, okay? So for the next one we'll use NYY, and NYX and NYY, okay? But that's the idea here. At the end of this, same thing exactly, except it's on X0, so we're animating this, okay, based on the Y. So this is gonna be the vertical pixels, all right? That's it. This is basically the entire algorithm, okay? It's quite simple. Few errors, okay? First of all, we don't clip this, so we will get index out of bounds exceptions, okay? Secondly, we don't do anything with the void pixel. So there's two problems with this that we need to figure out. This is going to be a very long episode. I'm considering breaking this up into two, actually. I probably will, okay? So we'll get the basic stuff working, and then we'll split it up. Next episode. So because I really wanted to get my explanation down on this because I know a lot of you guys are going to be really interested. So this is so we've done this, right? But you can see that we spill out of the bounds. So we need to cover that. So how do we know what the bounds are? Absolutely. Less than 0 and greater than width. Okay? Less than 0 and greater than height. Yeah? We know that stuff. So what we do is we say that if XX, so it's easy to detect, right? If XX is less than 0 and XX is greater than or equal to width, okay, width being the width of our sprite, make sure it's not, if you call it something different, make sure you don't go this.width, or basically, well, I don't remember that whole thing, or basically if you call this W, make sure you don't go width. We don't want the field, we don't want the width of our actual window, okay, which is this width. We want to make sure it's the width of the sprite. That's what we're interested in. Okay, and YY is less than 0, YY is less than, greater than equal to height. So it's easy to detect, but then what do we do? So now we have to decide. I'm going to say we're just going to give it kind of like a void color, Okay, so like pink, for example. Pink is kind of like our transparent color, or basically a color that will be transparent, okay? So let's set up a color variable. We'll just set it equal to 0 for now. Here, we'll set it equal to pink, okay, which is FF00FF in terms of a 24-bit RGB color with 1 byte per channel, or 8 bits per channel. That's that, right? Otherwise though, otherwise, so else, if it doesn't exceed the bounds, then we'll set the color equal to this, because these are the bounds that we're worried about exceeding. So we'll put that here, okay, and obviously here we'll set it equal to color, whatever that color may be, either pink if it's void, or the actual real color if it's actually within bounds. Done, okay? Simple as that. That solves 2 problems. The clipping, so now this will get clipped, okay? And it also solves, so this will get clipped now. There you go, clipped. A nice clipping animation for you guys, me moving that thing. Come on, work with me here. No, it doesn't want to move. Okay. Choose the arrow keys. It's gonna clip that, right? Well, it's not gonna, this is actually part of this, but anyway. And it's also gotta make sure that all of these white spaces that result from the rotation, yeah? Or in this case, I guess you'd call them the transparent parts, yeah? They will become pink. It'll fill it in with pink. All right, there you go, done. Okay, simple as that. Let's test this out in action. So what we want to do, let's see this in action, I should say. What we want to do here, we've actually already set it up, haven't we? So all we need to do really is go back to Wizard Projectile and change the angle to be, for it to use the new render method. All right, and now let's launch it and see what we see. So if I go up over here and I try and fire, okay, so we're getting a bunch of pink things. So, and then there's our arrow. So clearly we've done something wrong here. So let's go back into the code and see what we missed. All right, so let's see, and it looks like, so usually, so make sure this is obviously Y1 and Y whatever. Usually all these problems, by the way, when you get good, I guess, experience at debugging, you'll notice that usually the problems stem from you. If there's 2 components like X and Y, you just forget to actually use the proper versions, yeah? So I put X1 twice instead of X1 and Y1, and that was the problem, okay? So if we launch this again, what we'll see is, check this out. So it's working, okay? It looks really weird because it looks like this is going sideways. One thing I really want to do actually is go to Wizard Projectile and slow down the size to 1. So the speed is 4, not the size, the speed. The speed was 4, let's put it down to 1 here real quick. And if we go over here, somewhere we can see and we shoot, you can see it's correct, yeah? So it is rotated, yeah? It's just, it looks like it's just not rotated properly, all right? And this comes down to exactly the way it works. If we cast it right, yeah? What is right? That looks like a weird arrow, but right is 0 degrees based on the unit circle that I showed you guys, right? That's 0 degrees. So, well, we kind of want that to be 0 degrees in a way. And then there's that pink void stuff that I was talking about, right? So there it is. And then the other parts are just getting clipped, which is fantastic. We don't get any index head bounds errors ever. So really the problem is we want to offset the rotation. How do we do that? Well, the easiest way to do that is just to go into screen here, and instead of going by angle, we'll rotate it. How much do we want to rotate it by? We want to rotate it by -90 degrees, okay? Because if we look at this, yeah, and we fire right, yeah, we want it to be rotated clockwise. And remember, clockwise is negative on the unit circle, so thus -90 degrees. -90 degrees is equivalent to pi over 2 radians, okay, or half of pi radians, okay? So we simply go math.pi divided by 2 in our rotation x and rotation y, and that'll just essentially get us to the right thing. We could have also done this in the angle for Wizard Projectile, but I thought since this is going to apply to pretty much anything we do, it's better just to put it here in the actual method. So if we go back to this thing and we try and launch it, you'll see that, oh, look at that, that arrow is heading in that direction and everything looks fantastic. Again, the rotation looks kind of weird sometimes, but if we do put the speed up to 4, then you'll see that really it's kind of hard to actually notice that the arrow looks weird. Okay, the other thing we get is the pink stuff. I'm sure you guys know how to remove that, right? All we need to do is simply say in the color here that if color doesn't equal our alpha color, it's actually already in there. It's just that our alpha color is set to have an alpha channel. I mean, it's even called alpha color. So we should probably go down here and add the FF at the front, right? The reason I did it this way is just so that you can actually see the pink stuff that was getting added in based on the void stuff. And now you can see we don't get it. So there you go. There is our rotation. Now, there's a big problem with it. It's not really a big problem, but there's one thing stopping this from being perfect, and that is performance, okay? If we check this out, when we go into multiple mobs firing, if you look up the frame rate, I mean, I just dropped to about 60 frames per second, okay? If you look here in the bottom of the screen. And if I get out of here, obviously, we'll go back up to like 3,000. Yeah, there you go. So what's the problem? The problem is this rotation method is being called in a nested for loop every frame for a projectile. That is an insane amount of times, okay? If I was to quickly measure how often this rotate method was actually called, remember this rotate method isn't a walk in the park. It calls external methods like 6 times, right? These two methods, which are cosine calculations, and it's got a nested for loop that copies and modifies everything in here, okay? That's a lot of calls, okay? That's a lot of data to actually process. And this rotate method, if I was just to quickly measure how often it actually runs, how many times per second. So we'll go rotate plus plus here, and we'll make a static integer here. We'll go back to game, and inside here where we print the per second kind of stuff, we'll add in, so we'll just go screen.rotate plus per second, all right? And then we'll set it equal to 0 when we're done with that. If we look at this, and I go down here, look at that. That is absolutely ludicrous. Check this out. Over 1 million times per second. Over 1 million times per second. And it looks like it went no less than 780,000. Okay? That is ridiculous. We do not want to call such a heavy, expensive algorithm that many times, especially because we don't need it that many times. Once an arrow is thrown, its direction never changes. Okay? It stays on that constant angle. Okay? So what we're going to do next time is avoid doing it that many times. Look, if I fire, it's not, right now it's doing 0 per second. If I fire an arrow, 174,000 per second. Yeah? Straight away. That's absolutely ridiculous. So we don't want to do that. Alright? So next time, we're going to fix that up and make sure it doesn't do it every frame. If you guys enjoyed this video, please hit the like button. It really helps me out, and of course, it lets me know that you guys are looking forward to these videos and motivates me to do more. If you guys have any questions, be sure to post them in the comments below or on my forum, and I'll see you guys hopefully in 2 days or so with a new episode of Game Programming. So yeah, have a good day, guys. Goodbye.